Namaste. In this lecture we shall be looking at the methods of measuring heights using similar triangles, also known as the shadow and stick method of measurement of heights. So, to begin with, consider two triangles ABC and DEF. Now, if we say that triangle ABC is similar to triangle DEF, it would imply that we are saying that angle A or angle BAC is equal to angle EDF, angle ABC is equal to angle DEF, angle ACB is equal to angle DFE, and also that the sides of the triangle are in a constant ratio, or AB by DE is equal to BC by EF is equal to AC by DF, which would be equal to some constant K. So, by using this method of similar triangles, so we will have a method of similar triangles. If we can show that two triangles are similar, and if we were able to measure two lengths, say L1 and L2, then because all the lengths of the first triangle and all the lengths of the second triangle are in a constant ratio K, so we would be able to get the measurements of the second triangle just by taking the measurements of the first triangle. So, the steps would be to show that the triangles are similar. Second, find K. So, we can find K by taking one measurement of both the triangles, the corresponding measurements of both the triangles, and then use K to find lengths of triangle 2. So, how do we use this method in the field? So, the first way of using this method would be using shadows. Now, as we know, if we have a source of light and if we keep some object in front of it, then the rays of light get blocked by this object, and on the screen we would be having a shadow. So, this region would be black in color because it is not receiving any light from the source, whereas the top and the bottom portions would be illuminated. So, here we have a shadow. So, the first concept here is how shadows are formed. So, a shadow is formed because these light rays are moving in straight lines, because if they were able to curve around this object, then maybe they would have reached this portion, or maybe they would have reached this portion as well, but this does not happen because light travels in straight lines. The second concept would be to know about how these rays of light are at a distance. So, for instance, if we consider the sun and we have the earth that is at a very great distance from the sun. So, here the rays of light would appear to be nearly parallel. So, these are parallel rays of light, and especially if we consider a small portion on the surface of the earth, then we can take this approximation very easily that all the rays of light are parallel when they are reaching this point. This is because the sun is at a very great distance from the earth. So, now that we know that the rays of light are parallel, so suppose we have this ground, and suppose let us draw two parallel rays. Now consider two objects. One object is your tree. So, here you have a tree, and the second object is, say, a small stick. So, we have a stick and we have a tree. Now, the rays of light, let us draw another ray that is parallel to this. Now, this ray is intercepted by the object and is not able to reach the ground. So, this thing is our ground. So, this ray of light, it is intercepted by the object and so is unable to reach the ground, whereas this ray of light, it has just touched the surface, the top of the object and is able to reach the ground. Any ray to the right of it would be able to reach the ground because it is not intercepted by the object. So, what would that result in? It would result in a shadow. So, here we have a shadow. Here if we had another ray of light, it would be able to reach the surface, and so this portion is illuminated, whereas the portion to the right of the object is not illuminated. Similarly, in the case of this tree, because of its greater height, it will form a larger shadow. So, this is the shadow of the tree. Now, let us consider these two triangles. We have triangle ABC and the triangle DE and F. Now, because the rays of light AC is parallel to the ray of light DF, so we can say that these two angles are equal, because these are two parallel rays of light that have been intercepted by the ground. So, the angle subtended by these two rays to the ground would be the same. So, we can say that angle ACB is equal to angle DFE. Now, because both of these objects are said to be vertically above the ground, so both these angles are equal and equal to 90 degrees. So, angle ABC is equal to angle DEF is equal to 90 degrees, and suppose this angle is theta. Now, we know that in a triangle the sum of three angles is equal to 180 degrees. So, in the first triangle, in triangle ABC, we have angle A plus angle B plus angle C is equal to 180 degrees. Similarly, in triangle DEF, we have angle D plus angle E plus angle F is equal to 180 degrees. From both of these, we can say that angle A plus angle B plus angle C is equal to angle D plus angle E plus angle F is equal to 180 degrees. So, now we have seen here that angle C and angle F, angle C is the same as angle ACB and angle F is the same as angle DFE. So, angle C and angle F are equal, angle B and angle E, B and E are equal to 90 degrees. So, they also cancel out. So, we have angle A is equal to angle D. Angle A can also be written as angle BAC is equal to angle D or EDF. So, in these two triangles, so let us now again consider these triangles. So, we have seen that in triangle ABC and triangle DEF, we have angle A is equal to angle D, angle B is equal to angle E and angle C is equal to angle F, which implies that triangle ABC is similar to triangle DEF. So, what does that tell us? It tells us that the corresponding sides of the triangles triangle ABC and triangle DEF are in a fixed ratio, say K, which means that AB upon DE is equal to BC upon EF is equal to AC upon DF is equal to K. Now, we are interested in knowing the height h of this tree. Now, because we have taken this stick, so we can measure its length and suppose it is L. So, this equation would tell us that AB, which is equal to L, upon DE, which is equal to h, is equal to BC. Now, BC is the length of the shadow that is casted upon by the stick at this time. So, BC is equal to x. EF is the length of the shadow casted upon by the tree. So, x upon y. So, in this equation we know L, we know x and we know y. So, we can get h is equal to L into y upon x. So, by using the method of shadows, we can find out the height of a tree. What are the measurements that we need? We would need the length of stick, length of shadow of stick, and the length of shadow of tree. Now, both these measurements have to be at the same time and nearby locations. So, by using this we can figure out the length of the tree. Now, another way in which we use the method of similar triangles is called the single pole method. So, we are considering the methods of similar triangles. Now, what is the single pole method? In the single pole method, we have an observer who extends his arm and then holds a stick to his arm in such a way that the length of the stick, so suppose this is our observer, so this is his arm and he is holding a stick, so this is the stick, and he holds it in such a way that the length of his arm and the length of the portion of the stick that is above his arm. So, this stick, the total length is say 1.5 meters. So, this length would be 1.5 minus L . So, he is holding this stick in such a fashion that the length of his arm and the length of the portion of the stick above his arm is the same. Now, he takes this stick and then he goes into the field and there he sees a tree. So, what does he do now? So, suppose, so he is standing at the same level. Now, our observer will either go towards the tree or will go away from the tree to ensure that from his eye the top of the stick and the top of the tree come in the same line. So, when that is done, let us form two triangles now. Draw a line from his eye to the tree, and suppose this is the axis of the tree, So, in these so now let us take a vertical from here. Now consider these two triangles. The first triangle is this ABC, and the second triangle is this D, E and F. Now, because this length is a small length, so we can consider that in these two triangles we will have this angle is equal to this angle. Both these angles are 90 degrees, and this angle is equal to this angle. So, which would make our both these triangles similar. So, now looking at the slide now. So, now we have a tree, and we have a tree of height b at a distance capital A from the observer. The observer has held the stick in such a form that A is equal to B, where A is the length of his arm and B is the length of the stick on the top of the arm. And now the observer has moved forward and backward such that the top of the stick and the top of the tree are in the same line. So, then we will have two similar triangles, and in these two similar triangles we will have small a by small b is equal to capital A by capital B, because in these two triangles we have small a and small b, and we have capital A and capital B. So, in these two triangles we have small a by small b is equal to capital A by capital B is equal to some constant k. Now, because small a and small b have been kept in such a way that A is equal to B, so this ratio is equal to 1. So, once the observer has achieved this location such that the top of the stick and the top of the tree are in the same line, so at that point he can say that the length A will be equal to the length B. Now, the length B is equal to the height of the tree, and the length A is this distance from the observer to the tree, which can very easily be measured using a tape or say a range finder or by some other ways. So, when this is achieved, then we can very easily get the h. A third way of using the method of similar triangles is the use of a device known as a Christian hypsometer. So, looking at the slides now, a hypsometer is a very simple device. So, it is either made of wood or it is made out of metal or made out of plastic or say cardboard. So, it can be made out of any simple materials. The instrument is in the form of a strip with two flanges. So, suppose this is your instrument made out of cardboard. On this side you will mark the scales. So, you can take measurements from this side. One end of the hypsometer would be connected to a thread to suspend it, and the other end would be connected to a weight, so that the hypsometer is kept vertical at all times. The length of a hypsometer is generally taken to be 33 centimeters or roughly a foot. The hypsometer is always used with a staff. Now, a staff is a pole that is generally taken to be of the length of 3.6 meters. So, how is this hypsometer used? If you have a tree and this is your ground level, so you have a tree here. So, you keep the staff right next to the tree. So, you know that this length is equal to 3.6 meters. Now, the observer stands at a distance from the tree and he ensures that when he is looking at the top and the bottom of the tree, then he keeps the hypsometer in such a way that the top and bottom of the tree subtend the same ray as the top and bottom of the hypsometer. And then he looks at the top of the staff and then he takes a reading h. So, suppose so this length is h prime and the total length of the hypsometer is capital H prime. Suppose the height of the tree is capital H and the height of the staff is small h. So, in this situation we get that in this triangle, so let us label the triangles. So, A, B, C, D and E. So, now in triangle D, E, F, G. So, in triangle A, B, C and A, F, G. So, we are considering these two triangles. One triangle is AFG and the second triangle is the extension. So, in both these triangles we have that BC is parallel to FG because both of these are vertical to the ground, because your hypsometer is attached to a weight and this tree is growing vertically on top of the ground. So, both these sides BC and FG are parallel to each other. Now, this angle AFG is equal to this angle ABC because we have two parallel lines that are cut by an intersecting line. We have angle AGF, or this angle is equal to this angle ACB, and this angle is a common angle. So, angle FAG is equal to angle BAC. So, now we have that triangle AFG is similar to triangle ABC. So, in this situation we will have that the corresponding sides are in a constant ratio. So, we have AF by AB is equal to GF by BC is equal to AG by AC. Now, GF, this length is the length of the hypsometer or H prime, BC is the height of the tree or H. So, this is equal to H prime upon H. Now, similarly we can say that in this triangle so now we consider these two triangles, triangle AEC and triangle ADG. In both these triangles we have a common angle, this angle and this angle. So, angle ADG is equal to angle AEC because again we have two parallel lines that are intersected by a line. Also, angle AGD is equal to angle ACE and the common angle DAG is equal to angle EAC. So, both these triangles are also similar, which would give us that the corresponding sides are in a constant ratio. So, we have AE by AD is equal to EC by DG is equal to AC by AG. Now, here we have that dg is equal to small h prime, or the or this part of the hypsometer that is being subtended by the staff. EC is the height of the staff, which is normally taken to be 3.6 meters, is equal to AC upon AG. So, this would give us that H prime upon H is equal to, taking the reciprocal of this, AG upon AC. Now, previously we have seen that AG upon AC is equal to H prime upon H. So, this observation and this observation would together give us that AG upon AC is equal to H prime upon H is equal to small h prime upon small h. So, we have that H upon H prime. So, H is the height of the tree divided by the length of the hypsometer is equal to small h upon small h prime. Small h is the length of the staff and small h prime is the portion on the hypsometer that is subtended by the staff. So, in this way we can figure out the lengths of the triangle. So, now let us look at an example. For a 24 meters high tree, the staff length is 4 meters and the length of the hypsometer is 33 centimeters. So, we need to find h prime. So, we have a tree this is our hypsometer, and we are given that the height of the tree h is equal to 24 meters, the length of the hypsometer or h prime is equal to 33 centimeters, the length of the staff or small h is equal to 4 meters. So, it is not 3.6 in this case, it is 4 meters. We need to figure out this length, or h prime is equal to question mark. So, using the relation h upon h prime is equal to small h upon small h prime, we get capital H is 24 meters divided by h prime is 33 centimeters is equal to small h, that is 4 meters, divided by h prime. So, centimeters and centimeters get cancelled away. We have h prime is 4 meters into 33 by 24. Now, 4 6 are 24, 3 is 11, 3 2 are 6 is 5.5 centimeters. So, we can figure out what is the length that is subtended by the staff on the hypsometer. So, this is how we are going to solve it. Now, let us look at another problem. So, as you can see on your slides, so this is an inverse problem. For a tree, the staff length is 4 meters and the length of the hypsometer is 33 centimeters. We measure h prime to be 5.5 centimeters as we did in the previous case. Find the height of the tree. So, in this case we are asked to do the opposite thing. So, we have a tree, we have an observer who is looking at the top and the bottom of the tree through a hypsometer. We have a staff that is added right next to the tree and the observer is looking at the top of the staff. So, here we are given that for a tree the staff length is 4 meters. So, we have small h is equal to 4 meters. We are given that the length of the hypsometer is 33 centimeters. So, h prime is equal to 33 centimeters and we measure small h prime. So, this distance small h prime is 5.5 centimeters. We need to calculate capital H, that is the height of the tree, is question mark. So, again using the relation h upon h prime is equal to small h upon small h prime, we get capital H upon h prime is 33 centimeters is equal to small h, that is 4 meters upon 5.5 centimeters. So, we get h is equal to 4 meters by 5.5 centimeters into 33 centimeters. So 11 3s are 33, 11 5s are 55, 5 2s are 10, is 4 3s are 12 2s are 24 meters. So we can calculate that the height of the tree is 24 meters. So let us now look at some advantages of using this method or of using the hypsometer. One, the hypsometer is light and is easy to transport. It can be made out of wood, it can be made out of metal, it can even be made out of a piece of cardboard. So it is very light and it is easy to transport. It is very simple and easy to make. You can make it at your home as well using a piece of cardboard. It is quick to use out in the field, and there is no need to measure the distance from the tree. So you only need to measure the length of the staff, and the length that the staff subtends on the hypsometer. These are the only two readings. Now the length of the staff will always be known to you because you will be using a fixed staff for your measurements. So you need only one measurement and you can calculate the height of the tree. Now the disadvantages of using a hypsometer are these. The top and bottom of the tree should match the flanges, and so as we saw in the diagram. So if we move back to the tablet, so the top and the bottom of your hypsometer, so this is the top, this is the bottom, it should match the tops and bottoms of the tree. So you need to have some care while using this device, and both of these need to match exactly, otherwise you will have some errors. You need to hold the hypsometer on a vertical plane. So to hold it on a vertical plane, you add this string on top and you add a weight at the bottom. So this is just to keep it vertical. But even after doing this, it might become difficult in situations when you have a breeze of air flowing through. So if you have a windy situation, your hypsometer might sway, and when it sways, then you have chances of error creeping in. Then you will also have some amount of fatigue that is caused by holding your hypsometer like this in a vertical plane. So when you are keeping it like this for prolonged durations of time, your hands will start aching. And also you need to have considerable amount of skill to have a consistent accuracy. So these are the disadvantages of using a hypsometer. So in this class we looked at the methods of similar triangle, we looked at the methods of finding out the height of a tree using shadows, using a pole, and using a hypsometer. So these are the shadow and stick methods of finding out the heights of a tree. Thank you for your attention. Jai Hind.